Hello, Robert. Thank you for coming to visit us.
I am very excited to be here in a loudspeakers manufacturer site. But we don't to know right now the history of the PSI audio. So when you start, when you want.
Okay. So PSI Audio was founded 40 years ago in 1977 by Alain Roux, who's now retired. And Alain's idea was that a speaker should just do one single job. It should transform an electric signal into an acoustic signal, and it should do that as accurately as possible. In those days, most speakers were developed and manufactured a bit like musical instruments, where you had to listen to them and a speaker had to sound good and very nice. But that was not his idea. His idea that it should be accurate, and we shouldn't be the creative people. We should just translate what the musicians and sound engineers do so that everybody else can appreciate what their work has done. So that's been always the aim, is to reproduce sound as accurately as possible. And of course, speakers that we developed and manufactured evolved as the measurement instruments evolved also. But this has always been the game, is sound reproduction, to be able to hear what the real artists and sound engineers wanted, to recreate the emotion that you can get when you listen to a live music, yes. So that's always been the goal.
So you can say me the steps in your history from the beginning, the highlights of the history of PSI?
Yeah, so, well, 1977, we started making speakers, and that was in Alain Roux's garage in Alamont on Lake Geneva. And he made speakers that were all passive, multi-way speakers, accurate, that started being used for hi-fi, but also a little bit in studios and broadcasting. Then he developed a range of public address speakers. So the aim of public address is to be robust and loud and to be able to bring enough sound for people to hear it, but also good quality. So we did that for a very long time. And in 1988, built this the factory where we are here in Yverdon-les-Bains, about 50 kilometers north from where he was. And here moved his anechoic chamber to this building here where it stays, so the same anechoic chamber. Started manufacturing also cabinets, the wooden cabinets, started manufacturing them in Sainte-Croix, so about 30 kilometers up in the mountains. So we had a carpentry shop manufacturing those. And we started manufacturing also other speakers for other hi-fi brands as a original equipment manufacturer. So that was 1988. We came to Yverdon and started also manufacturing for other brands. Then a famous Swiss company called Studer came, depending what language you speak, came to us, and they wanted to develop active speakers to use in studio. So Studer makes professional equipment, and they wanted some active speakers to go in their professional environment. So the idea with an active speaker is that you have an engine, a motor, an amplifier that's perfectly adapted to every one of these membranes, and inside it's like having an engine adapted to the car or the motorbike that you're driving, and not choosing a car and then choosing another engine that's somewhere remote from the car. So that was the idea. So we developed active speakers for Studer, and we stopped manufacturing PSI because we were too busy making active speakers for Studer. So we were operating as an OEM manufacturer for several years until Studer was acquired by another group, an American group that owned another brand of loudspeakers. So understandably, they discontinued the contract they had with us, and they stopped buying speakers from us. But as the whole development belonged to us, and we'd done all the development of these speakers, we relaunched our old brand, PSI Audio, and with the technology that sort of evolved from the Studer days. And now we sell these speakers ourselves. It's our brand, PSI Audio, that we sell around the world from the early 90s again.
But you never stopped to manufacture loudspeakers. There was another brand, but you ever manufactured from 40 years ago.
Since 40 years ago, our job has been developing speakers, manufacturing speakers, yes, and that's what we do.
And
we never stopped.
How do you feel when a brand like Studer calls to you and say, hello, I need that you make my Lotus speakers? Because Studer is very big, it's maybe the biggest brand in Europe from broadcasting equipment.
Yes, well, it was very. I mean, of course, they went to see lots of loudspeaker manufacturers, and the fact that they chose us and was a lot to do with the history that we'd done, what Alain Roux had done and developed with them, and I think that brought a lot of credibility. I think it was also quite important for them to have it Swiss made, of course, because Studer is a Swiss company. So I think all these things contributed to them choosing us. But of course, we were very proud, and Alain Roux often talks about it, and it was a change in the company from being a small passive speaker to supplying one of the biggest flagship companies in professional audio, yes.
The PSI are an evolution from the Studer models, or are the same as the Studer models?
No, it's a new evolution. We always try and do better and better, and we always find better components, better designs, and we've had several. The outside of the speaker hasn't changed much, but there's been a lot of little improvements. Our goal is always to be as accurate as possible in frequency response and phase response, and this over the widest possible bandwidth, and to be able to create the maximum pressure, so the loudest sound SPL. So it's always been flattest response, widest band,
in the magnitude, in the phase.
In magnitude and in phase, to be able to go as wide as possible in bandwidth, and that's mainly in the low end, and to go as loud as possible without distortion. That's always been the game. And with this, we've improved quite a bit, well, by little steps, since over the last 25 years, of course, yes. So PSI audio, the ones we do now, are the normal evolution of what of the Studer monitors that we manufactured 25 years ago.
And these are the goals under you are manufacturing and designing the loudspeakers. But how you can achieve that goals? Can you explain us some of your patents or ideas to improve loudspeakers?
Well, we can go into a lot of technology, but I mean, I think that the basic philosophy that you have to do is you have to make sure that what you do is correct. There's a lot of psychoacoustics in listening to things. So you have to be able to measure somehow, whether it's with instruments or with people listening, and you have to be able to reproduce it. So you have to kind of define how you're going to develop things, and then it's a lot of attention to details. I always say a perfect speaker is the sum of many, many perfect details that all have to be done properly together and linked together. You can't just choose a box, choose a transducer, choose an amplifier, and just put it all together and expect it to work. It all has to be designed together. The size of the cabinet, the port, the driver, the weight, the magnetic field in it, the strength that it has, all these things have to be adapted. The amplifier has to be perfectly adapted to it. So it's really building a system with lots of elements that have to integrate perfectly so that the whole thing works perfectly together. So I think that's the philosophy, is a lot of attention, and each time you change something, it has the influence on something else. So you really have to play around with all the components to make something that's perfectly integrated and works. Yeah.
All the speakers are manufactured here,
yes,
in your facilities. Why not to subcontract another sites that they are cheaper?
We're not looking at making cheap things, cheap speakers. We're trying to do the best speakers we can, and we like having a continuous supervision over everything we do. We like keeping the entire knowledge, not only of the design but also of the manufacturing in-house. So for us, it's very important to continue making all the little components ourselves. That's very important. It's only like that you understand and you can optimize things. So that's the reason. And then what we like doing is building products also that are going to be professional tools that you can keep for decades and decades and decades and all your life, and pass them on to your next to your children or your colleagues. And I think that we like making a durable product. People come back to us after 35 years and say, can you repair this product? And we say, yes, we can repair it, and it goes back out for another 35 years. So I think the price of the initial investment has to be reasonable, of course, but I think we like thinking of a product that you're going to keep for many, many years, and that has to make sense, yeah. So we could compromise on quality to make something cheaper to sell more immediately, but that's not at all what we're looking for. We're looking for steady, long-term growth of a durable and sustainable product.
Mm-hmm. And are you now working in another advances for loudspeakers? Are you having some ideas to revolution the loudspeakers world? Are you constantly in research in loudspeakers technology?
Yes, well, I think research and development is a long-term investment, whereas marketing is the short-term investment, and we spend research and development as marketing. That's why we're not very well known, but this is what allows us to develop things like the first active sound absorber here. So we're constantly looking at how we can improve things, and there's still a lot of things that can be done in acoustics and audio and the way we produce sound, and we're constantly looking at new things, improvements, but also completely different ideas, radically different ideas on how to create pressure. But yeah, I mean, follow us over the next few years, and we hope we can produce some commercial products with all the research and development that we're doing. Yeah.
And what could you say me about the AVIA?
Well, the AVAA, it's the first active sound absorber. I mean, how it came about is that we make the most accurate speakers that we can. We put a lot of effort in it and a lot of detail, and we measure them and calibrate them individually in the anechoic chamber. And then we put them into a room, and we realize we've only done half of the job because the other half is in the room. And of course, rooms resonate, and they give you the sense of environment. That's very important. But it has to be balanced in the high frequencies, mid and low frequencies. High frequencies and mid frequencies are quite easy to absorb, to treat, but low frequencies are very, very difficult because the wavelengths are very, very long. So we've been thinking for the last 20 years or even more at putting our active technology to use, not to make sound, but to absorb sound. And this is what we managed to do with great difficulty and lots of fine-tuning. But anyway, after 3 years of working in collaboration with academic partners in Switzerland, we managed to develop a product that we now sell. And it's active bass trap that will absorb. It's not anti-noise, it's not anti-sound, it's absorption, and it will absorb sound between 15 and 150 hertz as effectively as something up to 20 or 25 times bigger. So it's really quite a revolution. It works extremely well on all the room modes that are very disturbing because they resonate for a long time in a room. And we managed to do that. Here you have to be extremely accurate. First of all, you have to counteract, you have to absorb extremely accurately in frequency, and in phase. So that's what we know how to do, get something to move very accurately in frequency and phase. And you have to be very quick in the counter reaction, in absorbing. So we measure the pressure that comes and we counteract. And this has to be immediate. And this we managed to achieve with analog technology, where we have almost zero latency. So I think what we were very proud of is that we could manage to balance something out and make it work, something that's simply physical, but we managed to make it with analog technology a lot easier than we did with the prototypes we made with digital technology. So I think that's a bit in a nutshell the AVA, how it works, what it's used, and somehow an idea of why we managed to make it with the competencies that we use in our speakers since 25 years, or semi-active speakers, yeah.
Could you explain us some of the problems when you design a loudspeaker, and how do you solve it?
Well, loudspeakers has got many problems, I would say, and it's always seeing how big the problem is, where the limits are, and then trying to counteract. So it's a compromise. You have to optimize them all together to achieve something that's the most that makes the most sense. But there's many problems. I mean, a driver is quite a complicated. It's not complicated, but there's lots of elements in it. It's a mechanical design. I mean, it's a mass on springs, but you have the mobile element itself. You have all the suspension. You have the material itself. You have the spider behind, and all of these things have to be perfectly adapted together. And you can't just change one and expect it to be fantastic. You really have to build it together. So I would say that's the main thing in the design of these transducers, to keep the maximum SPL with the minimum distortion in the range you want to use them. Then you have to match them together. So you have in the freeway speaker, you have three of these speakers that have to work perfectly together, and the sum of all three of them has to be perfect, has to be linear. So they have to be perfectly adjusted. The crossover has to have the right slope, and they all have the distortion has to be minimum around the crossovers, and also the dispersion has to be perfectly optimized for the type of listening you want to do. And you can improve some things and take away the others. This is obvious. But we're not scared of complexity, so we try and use as much complexity, but then you have to calculate very complex and then make it very simple again, so that it just works perfectly, and that you eliminate as much errors as possible. So yeah, there's many details go into the design, to the manufacturing, to the quality control, to listening. There's a lot of subjectivity also in a speaker. So you have to measure what you're doing. You have to do simulations and all this to get as right as possible. Then you build prototypes, and then you realize that it doesn't work the way you'd simulated it, so you have to start all over again. So it's always, I would say, what's fun also, but it's also one of the problems, the challenges, is to work on the scientific base, testing, listening, and so it is a combination of science and technology and simulations and empiric design and listening, I would say. Yeah,
some kind of patience.
Yeah, passion. And then you have to, of course, there's things that you can measure that you can't hear, and there's things you can hear you can't measure. So you really need both. But what is absolutely certain is that you need the measurements. Once you've decided, when you develop your speaker, you have to listen to it a lot and everything, but then you can fix, this is going to be my prototype. I've heard it, lots of people have listened to it in many rooms, this is what we want. But then you still have to produce. And producing, you can't start listening to your speaker in many rooms. You have to have some kind of criteria that you can measure in an anechoic chamber in certain conditions. So so measurement is it's paramount in production control and everything, but it's only part of the development of a speaker. Yes.
Mm-hmm. What could you say me about the innovations of PSI Audio in front of other brands?
Well, I mean, I think what makes us unique compared to others, there's different things, but first of all the type of amplifier we use is class GH amplifier. That I don't know many speaker manufacturers that use that. The advantage has the advantage of AB analog amplifier, but it doesn't have the disadvantages, as it uses a lot less energy with two voltage supplies. So class G amplifier is the one thing. Secondly, it's phase accurate, so we align the phases when they come out. Any type of filter, it can be electronic, but mechanical or acoustical, will affect the phases, the frequencies differently. So it's very important to align all of these frequencies again in phase when it comes out of the speaker. So this is something we do. We do it in a total analog way. So this is also something unique. I don't know any other speaker manufacturer that aligns the phase in an analog way. And then they are all handmade, and that is again to give enough attention to all the details and supervise all the quality. And each one is calibrated individually in our anechoic chamber. That is also unique. Each one receives a precision instrument, whether it's a medical instrument or an acoustic instrument, has to be calibrated, and you have to know that it works and it's going to do its job. So we have to calibrate every single one of them for quality control, but also calibration. And each one of them receives its birth certificate, its calibration curve, to show that it's there. So I think that's what makes us, those are all this technology. We have also a damping system that's electronic, so it's a feedback loop that will measure the speed of the membrane and give an information back into the amplifier and adapt the output impedance of the amplifier. And this is to dampen at all frequencies, because this element won't move the same way at all the frequencies, so you have to, this feedback loop has to be adapted perfectly to it. So all these things I think are quite unique, and the way we manufacture them by hand with so much attention to every detail in our factory here makes us quite unique, I think.
Okay, I have another question because I am seeing so many loudspeakers here. I want to know about the differences between all the loudspeakers. What are the main differences?
Well, again, the role of the speaker is to transform an electric signal in acoustic signal as accurately as possible, and they all do that. Okay, but when you go from a small box to a bigger box, it allows you to go lower in frequency with a bigger box. It allows you to go louder, and it also allows you to be tighter around the tolerances. So they all have the same philosophy. They all have the same they're all the same family. They're all PSI audio in the way that we manufacture them and design them with phase coherence and individual calibration. But when you go from a small box to a bigger one, you always can go louder, lower in frequency, and the tolerances are tighter, so they're more accurate. And this is the main difference. But the great thing also is, as they're all compatible in phase and frequency response, in any multi-channel system you can use a mix of big speakers and small speakers. So you can have the bigger speakers in the front and then smaller speakers at the back. It's not a problem. It works very well. And we also have this subwoofer that goes down to 24 hertz. And this is compatible with all of our speakers. We have a roll-off at the back, and when you roll off the speaker, it'll match perfectly, or the sum of the frequency and phase response of the speaker and the sub will give you something totally flat. So the subwoofer is like adding a low frequency extension towards like adding an extra way to the speaker. It's not like something separate that's going to give you a lot of low frequency. It has to be extremely accurate down to 24 hertz. And people love our speakers in all types of music, because you're translating electric signal into acoustic signal independently of what type of music you're listening to. So we sell a lot of speakers to people that work with classical music, people in doing dance music, electronic dance music or hip-hop. They like our low end that's very tight and very clean. People that do jazz and acoustic instruments, they really like our speakers because they can recognize their instruments. And yeah, so we sell them to all types of music production and sound engineers. Yeah.
I have another question about the subwoofer. What could you recommend us to have little speakers with a subwoofer, or to have a bigger speaker without the subwoofer?
I recommend big speakers with big subwoofers. All the time. We're the best. No, I don't know. I mean, the thing is, it depends a little bit on budget and configuration. But you have, with a big speaker, you have more accuracy, I would say. So that's something that is a given, and you can go quite low. You'll go down to the 35 hertz with something like this. If you want to go lower, then it takes up quite a bit of room. You know, you can have two of these with a subwoofer. It'll go down the same way, but you'll have less accuracy in the high frequencies with the mids and highs that you do with here. So I'd say it depends a bit on the configuration, budget. Buying two small speakers at a certain moment, and then you can probably invest in a subwoofer later on, is also an advantage. If you have two speakers that go low, of course you keep the stereo effect right down to the low end. If you have two speakers plus a subwoofer, the crossover is between, it's quite a soft crossover between 80 and 120. You'll only have the stereo effect above this 100 hertz. So yes, there's a lot of considerations. One of them is budget, one of them is space, configuration, and there's no best way or worst way, but yeah.
What is the most difficult about designing a loudspeaker? The most difficult?
I mean, the most difficult is keeping distortions to a minimum, and then I would say the low end is very difficult to have loud low end, accurate low end in a small cabinet is extremely difficult. Anybody can make something big with enormous woofers move in an uncontrolled way, but to have a very tight bass coming out of a small cabinet is I'd say one of the things that's most difficult to achieve.
Mm-hmm. Why did you decide to do the AVAA?
Well, we make the most accurate speakers we can and calibrate them in the anechoic room, and then we put them in a room and we realize that the room is part of the problem. Of course, when you listen to music in a room or sound in a room, you'll have the direct sound from the speaker that gives you the information on the sound source. So it has to be as accurate as possible. You don't want to modify that. If you're listening to a piano, you don't want to EQ the piano to be able to get rid of your room problems. The direct sound has to be as accurate as possible because it gives you the information of the sound source. But then you get all the echoes from the room, and that gives you the information on the environment you're in. And it's also very important that it should be balanced and allow to hear properly all of the sound source. But when you listen to music, when you reproduce sound in a room, you have the reproduction and then the room, and I think they're both equally as important. So basically, we've often put our accurate speakers in rooms that are very unbalanced, and it's not very fun. So we've been thinking about putting our active technology to use to absorbing room modes for quite a while. So a room, what's important in a room is that the acoustic environment is the same in all frequencies. So that means the response time, the reverberation time is the same in all frequencies. You don't want to feel as if you're in a dead room, very absorbed in the high frequencies with a lot of echo in the lower frequencies, because that'll tell your brain that you're in the mountains in high frequencies and in a cave in low frequencies. It has to be balanced. And unfortunately, to absorb low frequencies, you need an enormous amount of and thickness of passive absorption. So most small rooms we go into are extremely well treated in the mids and high frequencies, but they lack any sort of treatment in the low frequencies. And when you're in them, you feel as if you're in the mountains somewhere in the void in the mids and high frequencies, and you're in a cave in the low frequencies. So that's why we decided to really try and research and try and have a way of having an active way of sucking out these low frequencies. And these are the low frequencies coincide also with the room modes, and they will linger on and echo for a very long time in your room, and they're extremely disturbing because they give you false information. They also have a masking effect on the higher frequencies, so we really want to try and avoid them. So this is why we started working on the AVA, and we developed it, and we really wanted to find a system, and we're very proud to be able to have this product in our portfolio now that's patented also. Yeah, so that's basically in a nutshell why we developed it and what it tries to achieve.
If there is any person that is seeing the video and they are thinking, okay, I am passionate about loudspeakers and I want to begin to design my first loudspeakers, what will you do? What will you recommend to him?
If he wants to design his...
The first steps.
The first steps. Well, I'd say there's a lot of information on how to build your own loudspeakers. There's really lots of information on internet. So I'd say the first thing is to start reading and really understanding. And don't try and choose a transducer, choose a cabinet and choose wood and this. Don't do it. Really try and understand how things interact together. So I'd say there's a lot of information on internet. There's lots of little models you can use. So I think that's the first step. And the second step, well, do it. Do it, build it, listen to it, measure it, listen to it, improve it, and it's not, you're not going to manage to build a perfect loudspeaker straight away. It's a lot of trial and error, and I think that's what you have to be ready to do. That's part of the fun and process.